Hello there, and welcome to the Snoozing Ideas channel. I'm so glad you've joined me tonight. Whether you're winding down after a long day, trying to quiet an active mind, or simply seeking a moment of peace among the stars, you've found the perfect place to rest your thoughts. As you settle in, allow your breathing to deepen and slow. Feel the weight of the day gently lifting as gravity seems to soften around you. Tonight, we'll be floating through our cosmic neighborhood, the solar system, where ancient planets spin in their eternal dance, comets streak through the darkness, and gentle auroras ripple across distant atmospheres. These celestial wonders have been here for billions of years, and they'll still be spinning peacefully long after we wake tomorrow. There's something deeply comforting about that permanence, isn't there? Let's begin. The sun creates light through a cosmic alchemy at its heart. Deep within our star, hydrogen atoms fuse into helium at temperatures exceeding 15 million degrees Celsius, releasing extraordinary energy with each transformation. This process, called nuclear fusion, powers everything we see, from the gentle warmth on your skin to the light that grows forests and feeds life. Scientists calculate that every second, the sun converts over 600 million tons of hydrogen into helium. Some mysteries remain about the sun's precise internal workings. What would happen if we could replicate this perfect furnace on Earth? Like a cosmic hearth fire that never dims, our star continues its quiet, ancient rhythm of creation and release, illuminating our days and shaping our world. Jupiter's great red spot has been swirling in quiet permanence for centuries. This massive storm system has been continuously observed since at least 1665, making it perhaps the longest-lasting storm in our solar system. Scientists study it through telescope observations and spacecraft flybys, revealing a counter-clockwise vortex large enough to engulf 3 Earths. Recent measurements suggest the spot is gradually shrinking, though no one can predict when or if it might disappear completely. Like a deliberate painter's brushstroke on a cosmic canvas, this crimson oval continues its slow dance across the face of our largest planet, a testament to the enduring nature of even the most turbulent phenomena. Saturn's rings appear solid from a distance, but hide a more delicate truth. These elegant bands encircling the gas giant consist primarily of countless water ice particles, ranging from microscopic dust to enormous chunks the size of houses. Spacecraft that have passed through the ring plane reveal their structure through radio signals and imaging. Scientists believe the rings may be relatively young, perhaps formed when a moon or comet ventured too close and was torn apart by Saturn's gravity. Could they be temporary features in the planet's long existence? Each particle follows its own path, creating a collective shimmer that has captivated astronomers since Galileo first glimpsed them through his primitive telescope. Venus spins in quiet rebellion against the prevailing pattern of our solar system. Unlike most planets that rotate from west to east, Venus turns backwards, with a Venusian day stretching to 243 Earth days, longer even than its year. Astronomers discovered this retrograde rotation through radar observations bounced off the planet's surface. The leading theory suggests a massive impact early in Venus's formation may have reversed its spin. Perhaps the most peculiar aspect is how this creates a sun that rises in the west and sets in the east, a mirror image to our own familiar rhythm. On this cloud-shrouded world, time follows a different pace. a reminder that even fundamental patterns can be beautifully disrupted. The Moon is gradually distancing itself from our embrace. Each year, our cosmic companion drifts approximately 3.8 centimeters farther from Earth, a pace comparable to how quickly your fingernails grow. Scientists measure this recession precisely using laser reflectors placed on the lunar surface during Apollo missions. This separation occurs because Earth's rotation transfers energy to the Moon through tidal forces. Over billions of years, this tiny annual movement adds up. The Moon was once much closer, appearing larger in ancient skies. Like a child slowly gaining independence, our Moon continues its imperceptible journey away from us, altering our shared gravitational dance in the quietest possible way. Mars cradles the largest volcano in our solar system. Olympus Mons rises 21 kilometers above the surrounding plains, nearly 3 times the height of Mount Everest. This gentle giant was formed over billions of years as lava slowly accumulated from persistent eruptions at the same location. Unlike Earth with its moving tectonic plates, Mars allowed this volcano to remain fixed above its magma source. The volcano's base spans 600 kilometers, roughly the size of Arizona. Without wind or water erosion to wear it down, the mountain has preserved its massive form across eons. Like a slumbering titan beneath a rusty blanket, Olympus Mons rests on the Martian landscape, a testament to the power of patience and persistence. Neptune harbors the fastest winds ever recorded in our planetary family. Sweeping across this distant blue world, these atmospheric currents can reach astonishing speeds of 200 to 200 kilometers per hour, swift enough to cross the continental United States in just over 2 hours. These winds were measured by tracking cloud movements in images captured by the Voyager 2 spacecraft during its 1989 flyby. What makes these winds particularly puzzling is their source of energy, as Neptune receives only 1/900th the sunlight that reaches Earth. How could such distant, faint sunlight drive such ferocious motion? Like invisible rivers flowing through an azure sea, these persistent winds shape the ever-changing cloud patterns on this remote ice giant. Mercury experiences the most extreme temperature swings in our solar system. During its long day, surface temperatures soar to 427 degrees Celsius, hot enough to melt lead, while the night side plummets to minus 173 degrees. These dramatic shifts occur because Mercury lacks a substantial atmosphere to distribute heat. Spacecraft measurements have confirmed these variations through infrared observations. The planet's slow rotation means some locations endure months of scorching heat, followed by equally long periods of freezing darkness. In the shadows of polar craters, where sunlight never reaches, even this sun-baked world harbors ice deposits. Like a meditation on contrast, Mercury embodies both fire and ice, existing in perpetual balance at the edge of our star's embrace. Europa hides an ocean with more water than all of Earth's seas combined. Beneath a cracked, icy shell estimated to be 15 to 25 kilometers thick, Jupiter's moon contains a liquid water ocean with more than twice the volume of all Earth's oceans. Scientists detected this hidden sea through gravitational measurements and magnetic field observations. The ocean remains liquid despite its distance from the Sun because of tidal heating. Jupiter's gravity flexes Europa's core, generating warmth. This watery realm, protected from radiation by its icy ceiling, might be one of the most promising environments for extraterrestrial life in our solar system. Like a secret kept beneath crystal walls, Europa's vast ocean waits in darkness. its mysteries still largely untouched by human understanding. The asteroid belt holds millions of rocky remnants from our solar system's formation. Drifting in the space between Mars and Jupiter, these fragments range from dust particles to objects hundreds of kilometers across, with most smaller than 1 kilometer in diameter. Contrary to popular depiction, the belt is mostly empty space. A spacecraft passing through would likely never encounter a single asteroid. Astronomers believe these objects represent material that Jupiter's gravity prevented from forming into a planet. Across this celestial rockfield, sunlight falls upon ancient surfaces, unchanged for billions of years. Each silent stone carries the memory of our system's birth, turning slowly in the void, witnesses to cosmic history. Uranus rolls through space in an unusual posture among the planets. With a tilt of 98 degrees, this ice giant essentially orbits the Sun on its side, unlike its more upright planetary siblings. This extreme orientation was discovered through telescope observations and later confirmed by Voyager 2's flyby in 1986. Most astronomers believe a massive collision with an Earth-sized object early in Uranus's history knocked it sideways. This peculiar tilt creates seasons unlike anywhere else. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness. Like a cosmic oddity that refuses convention, Uranus reminds us that even in the precise clockwork of our solar system, anomalies and exceptions find their place. The solar wind flows outward from our Sun in an invisible river of particles. This stream of charged electrons and protons travels at approximately 400 kilometers per second when it reaches Earth's vicinity. Scientists study this flow using specialized spacecraft equipped with particle detectors. This constant outpouring shapes our space environment, creating the heliosphere, a protective bubble around our solar system. Where this wind meets Earth's magnetic field, a complex dance occurs, sometimes allowing particles to penetrate and create auroras near our poles. Might there be patterns in this flow we haven't yet recognized? Like a perpetual exhalation from our star, this radiant breath extends the Sun's influence far beyond its visible boundaries. Titan's surface flows with rivers and lakes, but not of water. On Saturn's largest moon, liquid methane and ethane fill depressions and carve channels across a landscape of water ice. The Cassini-Huygens mission confirmed these features through radar imaging and direct landing on Titan's surface. Under an orange haze and temperatures of minus 180 degrees Celsius, these hydrocarbons remain liquid, participating in a methane cycle similar to Earth's water cycle. Seasonal changes have been observed in the lake levels as methane evaporates and falls as rain. What might swim in those dark pools, if anything at all? Like Earth reflected in a strange mirror, Titan offers a glimpse of familiar processes playing out with exotic materials. A single day on Venus unfolds with extraordinary slowness. The planet requires 5,132 hours to complete one rotation on its axis, equivalent to 243 Earth days. This means a Venusian day is actually longer than its year, which lasts 225 Earth days. This peculiarity was discovered through radar astronomy, as Venus's thick clouds prevent direct observation of its surface. The combination of backward rotation and this extreme length creates a sun that moves very slowly across Venus's sky. Like a world caught in an endless moment, Venus turns with a patience beyond human comprehension, where dawn and dusk might be separated by decades in Earth time. The Kuiper Belt traces a distant ring of frozen worlds beyond Neptune. Extending from about 30 to 50 astronomical units from the Sun, this region contains numerous icy bodies, including Pluto and other dwarf planets. Astronomers first theorized its existence in the 1940s, but direct observation of its members only began in the 1990s. These objects are primarily composed of methane, ammonia, and water ice, preserved in deep freeze since the solar system's formation. The belt likely contains thousands of bodies larger than 100 kilometers across, most still undiscovered. Like a library of cosmic fossils, the Kuiper Belt preserves primordial materials from our solar system's birth, a frozen record of our beginnings. Io's surface constantly renews itself through unceasing volcanic activity. Jupiter's innermost large moon hosts over 400 active volcanoes, making it the most geologically dynamic object in our solar system. These eruptions were first spotted by the Voyager spacecraft and later studied extensively by the Galileo mission. The volcanism is powered by tidal heating. Jupiter's gravity, along with the pull of neighboring moons, stretches and squeezes Io, generating immense interior heat. Some volcanic plumes rise 500 kilometers above the surface. How might the moon's surface appear a century from now? Like a canvas perpetually painted and repainted, Io's face is never the same from one decade to the next. A world in constant creation. Our solar system emerged from cosmic dust in a relatively brief moment. Approximately 4.6 billion years ago, a collapsing cloud of gas and dust began the process that would create our Sun and planets. Astronomers have reconstructed this history through examination of meteorites and computer modeling. The initial collapse likely took only a few 100,000 years, while the planets formed over the following 100 million years. Analysis of isotope ratios in the oldest meteorites provides precise dating of these events. Would our system have developed differently if the cloud had contained slightly different elements? Like a family portrait from our deepest past, the arrangement of our planets preserves the memory of that ancient transformation from chaos to order. Saturn possesses a curious lightness despite its enormous size. With a density less than that of water, this majestic planet would actually float if placed in an ocean large enough to hold it. Scientists determined this by measuring Saturn's gravitational effects on passing spacecraft and its moons. This low density results from Saturn's composition, primarily hydrogen and helium, similar to Jupiter but with less heavy elements. Below its visible cloud layers, the planet gradually transitions from gas to liquid without a definite surface. Like an impossibly delicate balloon of cosmic proportions, Saturn drifts through space, its elegant rings belying the ethereal nature of the world they encircle. The Oort cloud forms an immense spherical shell at the edge of our solar system. This vast collection of icy objects extend from 2,000 to possibly 100,000 astronomical units from the Sun, nearly halfway to the nearest star. Its existence was first proposed by Dutch astronomer Jan Oort in 1950 to explain the origin of long-period comets. Though it has never been directly observed, its presence is inferred from the orbits of comets that visit the inner solar system. The cloud may contain trillions of objects, remnants from our system's formation that were scattered outward by the giant planets. What might we discover when we can finally observe these distant realms? Like a distant cocoon surrounding our planetary family, the Oort cloud marks the outer boundary of our Sun's dominion. Earth's magnetic field extends into space like an invisible shield. This protective bubble reaches approximately 60,000 kilometers into space on the side facing the Sun, but stretches much farther on the night side, forming a magnetic tail. Scientists map this field using spacecraft equipped with magnetometers. Generated by the movement of molten iron in our planet's outer core, this magnetic barrier deflects harmful solar radiation that would otherwise strip away our atmosphere. Historical records show the field's strength has decreased about 10% in the last 150 years. Is this a sign of an eventual pole reversal? Like a guardian that asks for no recognition, this unseen force has helped make Earth habitable for billions of years. Phobos races around Mars with unusual haste among moons, completing an orbit in just 7 hours and 36 minutes. This irregularly shaped satellite circles Mars faster than the planet rotates. Astronomers first calculated its swift orbit in the late 19th century after its discovery. From the Martian surface, Phobos would appear to rise in the west and set in the east, crossing the sky in just 4.5 hours. Tidal forces are gradually drawing Phobos closer to Mars, meaning that in about 50 million years it will either crash into the planet or break apart to form a ring. Like a child running circles around a parent, this tiny moon hurries through its days, unaware of its limited future. The Sun holds nearly all the mass in our planetary family. Though it makes up just one of many objects in our system, the Sun contains 99.86% of all mass present. Astronomers determine this through gravitational calculations and spectroscopic analysis of the Sun's composition. The remaining 0.14% constitutes everything else: planets, moons, asteroids, comets, and dust. This mass imbalance explains why the Sun's gravity dominates the orbital mechanics of everything in the system. Despite this overwhelming proportion, the Sun itself is fairly average among stars. Might the Sun's dominance change over billions of years as it loses mass? Like a parent surrounded by children, our star's presence defines and anchors the cosmic neighborhood we call home. Enceladus releases plumes of water vapor from fractures near its south pole. This small moon of Saturn, just 500 kilometers in diameter, harbors a subsurface ocean beneath its icy crust. The Cassini spacecraft discovered these geysers in 2005, flying directly through them to sample their composition. Analysis revealed water vapor, ice particles, salt, and organic compounds, ingredients considered essential for life. The energy source for these eruptions likely comes from tidal heating as Enceladus orbits Saturn. These plumes contribute material to Saturn's E-ring, connecting this tiny moon to the larger system. Like whispered secrets escaping into the void, these delicate fountains hint at hidden oceans waiting beneath frozen surfaces. Our entire solar system drifts through the galaxy like a cosmic caravan. Moving at approximately 230 kilometers per second relative to the galactic center, we complete one orbit around the Milky Way every 250 million years. Astronomers calculate this motion by observing our velocity relative to distant galaxies and the cosmic microwave background. During the age of dinosaurs, our solar system occupied a completely different location in the galaxy. The Sun also oscillates up and down through the galactic plane every 60 million years or so. What distant regions have we passed through in our long journey? Like silent travelers on an ancient migration, our planetary family follows the Sun as it traces its path around the galactic core. Jupiter generates the most powerful magnetic field of any planet, approximately 20,000 times stronger than Earth's magnetic field. This invisible force extends millions of kilometers into space. Scientists mapped its structure using measurements from multiple spacecraft flybys and orbiters. The field is created by electrical currents in Jupiter's liquid metallic hydrogen layer, which forms under extreme pressure in the planet's interior. This magnetic bubble traps charged particles from the solar wind, creating intense radiation belts that would be lethal to humans. Jupiter's moons orbit within this magnetic environment, which influences their surfaces and potential subsurface oceans. Like a vast, unseen architecture of force, this field shapes space around our largest planet into patterns of surprising complexity. Pluto maintains a complex relationship with 5 known satellites. The largest, Charon, is so substantial relative to Pluto that the two actually orbit around a common center of gravity located between them. Astronomers discovered Charon in 1978, while the 4 smaller moons, Nix, Hydra, Kerberos and Styx, were found between 2005 and 2012 using the Hubble Space Telescope. These smaller moons follow chaotic orbits, tumbling unpredictably rather than rotating steadily. The entire system likely formed after a massive collision between Proto-Pluto and another large Kuiper Belt object billions of years ago. Like a miniature planetary system at the edge of our own, Pluto and its moons dance in distant darkness, their movements precisely balanced, yet always changing. Solar flares erupt from our star with the energy of billions of hydrogen bombs. These sudden releases of magnetic energy appear as bright flashes in the Sun's atmosphere, heating plasma to millions of degrees in just minutes. Scientists monitor these events using space-based solar observatories that can detect wavelengths blocked by Earth's atmosphere. The largest flares can disrupt radio communications, damage satellites, and create beautiful auroral displays when their particles reach Earth days later. The Sun's activity rises and falls in an 11-year cycle, with flares more common during solar maximum. What triggers the exact moment of release remains incompletely understood. Like cosmic lightning on an unimaginable scale, these brilliant eruptions remind us of the dynamic nature of our seemingly constant star. Vesta carries a mountain of remarkable height among asteroids. Located at its south pole, this peak rises approximately 22 kilometers above the surrounding terrain. The NASA Dawn mission mapped this feature in detail during its orbit of Vesta between 2011 and 2012. The mountain formed as a result of a massive impact that created the Rhea Silvia Basin, one of the largest impact craters relative to body size in the solar system. Material from this collision was ejected and fell back to the surface, creating the central peak. This impact was so significant that it sent numerous smaller asteroids toward Earth, which we now identify as a specific class of meteorites. Like a scar that never fully healed, this mountain stands as testimony to the violent events that have shaped even the smallest worlds in our system. Earth traces an elliptical path around the Sun with mathematical precision. Our planet completes exactly 365.256 days per orbit, a number that remains stable over human timescales but changes slightly over millions of years. Astronomers measure this period using a variety of techniques, including observing the positions of distant stars relative to the Sun. This orbital duration reflects the perfect balance between Earth's velocity and the Sun's gravitational pull. The slight mismatch with our calendar year of 365 days necessitates the addition of leap days. Might our orbit have been different if Earth had formed slightly closer or farther from the Sun. Like a dancer following an invisible choreography, our world moves through space with a rhythm that has shaped the evolution of all life it carries. Jupiter's core endures temperatures that rival the surface of the Sun. Scientists estimate that at the center of our largest planet, the temperature reaches approximately 20,000 degrees Celsius. This extreme heat is generated primarily through the slow gravitational compression of Jupiter's enormous mass. Computer models suggest the core consists of rock, metals, and hydrogen compounds under pressures millions of times greater than Earth's atmosphere. The exact composition remains uncertain, as no direct measurements are possible. One theory suggests the core might be more diffuse than once thought, without a clear boundary. Like a furnace burning silently in the darkness, this intense heat at Jupiter's heart has persisted for billions of years, largely unchanged since the planet's formation. Ganymede stands apart as the largest moon in our solar system. This satellite of Jupiter exceeds even the planet Mercury in size, with a diameter of 5,268 kilometers. Scientists have studied its structure through gravitational measurements taken by spacecraft flybys and its reflectance spectrum. Beneath a varied surface of ancient dark regions and younger grooved terrain lies a differentiated interior with a metallic core, rocky mantle, and outer layer of ice. Ganymede is the only moon known to generate its own magnetic field, suggesting complex internal dynamics. What processes shape the patterns visible on its ancient face? Like a silent giant in Jupiter's court, this world contains enough volume to fit all the smaller moons in our solar system inside it. The heliopause marks the boundary where our Sun's influence gives way to interstellar space. Located approximately 120 astronomical units from the Sun, this frontier was directly measured when the Voyager spacecraft crossed it in 2012 and 2008. At this threshold, the outward pressure of the solar wind balances with the inward pressure of the interstellar medium. Beyond lies truly empty space, filled only with the thin gas and dust between stars. The shape of this boundary is not perfectly spherical, but is compressed on the leading edge of our solar system's motion through the galaxy. How might this region change as we move through different parts of the galaxy? Like the shoreline of an invisible ocean, this border defines the outer limits of our Sun's territory. Venus travels through space without the company of moons or rings. Among the terrestrial planets, only Venus and Mercury lack natural satellites. Astronomers have thoroughly searched the space around Venus using both Earth-based telescopes and spacecraft observations. The absence of moons may be related to Venus's retrograde rotation. Any early moons might have spiraled inward and crashed into the planet due to tidal interactions, or perhaps none formed to begin with. The lack of rings likely results from Venus's proximity to the Sun, where material would be difficult to maintain in a stable orbit. Like a solitary figure on a cosmic stage, Venus moves through its orbit, accompanied only by its thick atmosphere and shroud of reflective clouds. Mercury bears the scar of a catastrophic ancient impact. The Caloris Basin stretches 1,550 kilometers across the planet's surface, a distance comparable to the width of the continental United States. This massive feature was discovered in 1974 during Mariner 10's flyby, and later mapped in detail by the Messenger spacecraft. The impact that formed it released energy equivalent to hundreds of millions of nuclear weapons detonating simultaneously. The event was so powerful that it created a wave of material that traveled through the planet and disrupted the surface on the exact opposite side. Does Mercury hide other evidence of its violent past beneath younger features? Like a memory preserved in stone, this ancient wound remains visible billions of years after the moment of impact. Earth's atmosphere fades gradually into the emptiness of space. Extending approximately 10,000 kilometers above the surface, our gaseous envelope has no definite upper boundary. Scientists study its structure using instruments on high-altitude aircraft, rockets, and satellites. The atmosphere thins with altitude, transitioning through distinct layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Most weather occurs in the lowest layer, while the uppermost regions merge imperceptibly with the vacuum beyond. The composition also changes with height, with lighter gases becoming more prevalent at higher altitudes. What invisible currents flow through these rarefied upper reaches? Like music that slowly diminishes but never quite ends, our atmosphere extends its protection outward until it becomes one with the cosmos. Mars is attended by two small irregular moons unlike our own. Phobos and Deimos, named after the Greek gods of fear and dread, are just 22 and 12 kilometers across respectively. Astronomers believe these are captured asteroids rather than bodies that formed alongside Mars, based on their composition and irregular shapes. Both moons were discovered in 1877 by American astronomer Asaph Hall. These satellites orbit unusually close to Mars. Phobos circles just 6,000 kilometers above the surface, closer than any other major moon to its parent planet. As they travel, both moons always present the same face toward Mars. Like faithful companions that arrive by chance, these tiny worlds have accompanied the red planet for millions or perhaps billions of years. Neptune once harbored a storm system of extraordinary scale. Known as the Great Dark Spot, this anticyclonic storm was comparable in size to Jupiter's Great Red Spot when first observed by Voyager 2 in 1989. Scientists monitored its behavior through the spacecraft's detailed imaging of cloud movements. Unlike Jupiter's long-lived storm, Neptune's dark spot had disappeared when the Hubble Space Telescope observed the planet in 1994. New similar storms have appeared and vanished since, suggesting that such features are common but transient on this distant world. The mechanisms that create and destroy these massive vortices remain incompletely understood. Like weather patterns in a dream, Neptune's atmospheric features shift and transform across decades, visible only through our most powerful observing tools. Saturn's moon Mimas carries an impact crater of unusual proportion. Named Herschel after the moon's discoverer, this crater spans 130 kilometers, nearly one-third of the moon's diameter. The Cassini mission provided detailed images of this feature, showing a central peak rising 6 kilometers from the crater floor. The impact that formed Herschel nearly shattered the entire moon, creating fractures visible on the opposite side. Mimas's interior appears to be relatively uniform, unlike many other moons that show evidence of differentiation into layers. The crater's distinctive appearance has earned Mimas the nickname Death Star Moon in popular culture. Like a survivor of a near-fatal wound, this small world continues its orbit, permanently marked by its closest encounter with destruction. The solar constant measures the steady stream of energy reaching Earth from the Sun. At the top of Earth's atmosphere, this value amounts to approximately 1,361 watts per square meter, equivalent to the power of about 13 100-watt light bulbs striking each square meter. Scientists measure this value using specialized radiometers on satellites that avoid the filtering effects of our atmosphere. Despite its name, the solar constant varies by about 0.1% during the 11-year solar cycle. Over much longer periods, the Sun's luminosity has actually increased by about 30% since its formation 4.6 billion years ago. Might this gradual brightening continue into the distant future? Like a heartbeat of radiance, this energy flow sustains nearly all life and movement on our planet's surface. Uranus keeps company with 27 known moons, each carrying literary significance. All are named after characters created by William Shakespeare and Alexander Pope, rather than figures from classical mythology like most other planetary satellites. Astronomers have discovered these moons gradually. 5 were known before the space age, 10 more were found by Voyager 2 in 1986, and others have been located using ground-based telescopes since. These moons form a complex system, with some in irregular orbits likely representing captured objects. The largest 5, Titania, Oberon, Umbriel, Ariel, and Miranda, show evidence of past geological activity despite their small sizes. Like characters from different stories brought together, these varied worlds circle their aquamarine parent in a celestial ensemble. Our solar system rests within a delicate geometric harmony. The ecliptic plane, an invisible disk through which all major planets orbit, maintains a striking order, with planetary paths deviating by just a few degrees. This near-perfect alignment emerged from the same spinning nebula cloud that birthed our Sun 4.6 billion years ago, conserving its rotational motion. Astronomers use this plane as a cosmic reference point, a celestial equator against which all orbits are measured. Smaller bodies like comets and dwarf planets often wander at steeper angles, as if refusing the consensus. Yet, within this subtle flatness, 8 worlds turn like thoughts circling a single idea, each on its own path, yet bound to the same primordial pattern. Around Jupiter swirls an invisible ocean of deadly energy. Its radiation belts, 10,000 times stronger than Earth's Van Allen belts, form a lethal barrier surrounding the gas giant. These vast regions trap charged particles accelerated to near light speed by Jupiter's intense magnetic field. Space probes venturing too close require specialized shielding, their electronic hearts vulnerable to this invisible storm. The radiation is so intense it would kill a human in minutes. A silent, invisible death. Yet, in this hostile sea of energy, Jupiter's moons somehow persist, their surfaces darkened and transformed by the constant barrage. Here, at the crossroads of matter and energy, the largest planet holds court behind walls of pure radiance. Ceres drifts alone, a world between worlds. The largest object in the asteroid belt, this dwarf planet measures 940 kilometers across, a sphere of rock and ice wandering where a planet never formed. Dawn, the spacecraft that first orbited this distant body in 2015, revealed a cracked, ancient surface dotted with bright spots. Salt deposits where subsurface water once reached daylight. Though massive among asteroids, Ceres contains just 1.3% of our Moon's mass. Yet it holds most of the asteroid belt's water, a reservoir in the inner solar system's desert. Neither planet nor asteroid, but something in between, Ceres traces its silent path through cosmic twilight, belonging fully to neither category we've imagined. Venus breathes with the weight of an ocean above its surface. Its atmospheric pressure, 92 times greater than Earth's, would crush a human instantly, like being a kilometer deep in our seas. This thick blanket of carbon dioxide traps heat so efficiently that lead would melt on the surface, flowing like water. Soviet Venera probes, the only visitors to survive this hostile world, transmitted images for mere hours before succumbing. What's most striking is how this sister planet, nearly identical to Earth in size and composition, evolved along such a different path. In Venus's oppressive embrace, we glimpse an alternate history, perhaps our own world's distant future or unrealized past. The northern and southern lights paint our skies with the sun's invisible breath. When solar wind, a stream of charged particles from our star, encounters Earth's magnetic shield, a dance begins. Electrons and protons follow magnetic field lines toward our poles, colliding with atmospheric gases that glow in response. These curtains of green, blue, and rarely red light have inspired myths across human cultures. Messengers from beyond or spirits dancing in the night. Indigenous Arctic peoples saw them as the souls of ancestors. What appears as magic to our eyes reveals the unseen connection between Earth and Sun, a relationship written in light across the night, reminding us that we live within the extended atmosphere of our star. Hyperion tumbles chaotically through space, a moon that cannot find its rhythm. This irregularly shaped satellite of Saturn, pockmarked with deep craters, rotates unpredictably. The only moon in our solar system whose movement cannot be precisely calculated. Gravitational interactions with Saturn and its larger moons prevent Hyperion from settling into a stable spin. Its sponge-like appearance comes from impacts that compressed material rather than ejecting it, leaving deep, sharp-edged craters. Scientists studying it see patterns of chaos theory made manifest, a reminder that even in the clockwork solar system, uncertainty remains. Like a cosmic die still rolling through eternity, Hyperion turns in its unpredictable dance, never repeating the same rotation twice. Mercury races around the Sun in a brief cosmic moment. Just 88 Earth days, less than a single season here, comprises a full Mercurian year. This swift orbit comes from being the innermost planet, where the Sun's gravity pulls most strongly. The ancient Romans named it after their fleet-footed messenger god for this rapid motion. Yet, despite its hurried orbit, Mercury rotates slowly on its axis, creating days that last nearly 59 Earth days. From its surface, the Sun would appear to move across the sky, then reverse direction briefly before continuing forward, a cosmic illusion born of orbital mechanics. In Mercury's paradoxical rhythm, we find a world both rushed and patient, its perception of time unlike anything we experience. The Trojan asteroids follow Jupiter like cosmic courtiers, neither advancing nor retreating, positioned precisely at what mathematicians call Lagrange points, regions of gravitational stability 60 degrees ahead and behind the giant planet. These rocky swarms share Jupiter's orbit without ever approaching it. Their name comes from mythology. The leading group is named for Greek heroes of the Trojan War, the trailing group for Trojans. These points represent a perfect balance where the Sun and Jupiter's combined gravity creates stable pockets in space. Thousands of asteroids gather at these gravitational oases, ancient material preserved since the solar system's birth. Like leaves caught in eddies of a stream, they've found stillness within motion, held in perfect equilibrium by opposing forces. At Earth's core burns a temperature rivaling the Sun's surface. Approximately 5,700 degrees Celsius, a heat we can scarcely imagine, radiates from our planet's inner heart, where pressure squeezes iron into a solid despite this extreme heat. This molten outer core flowing around the solid inner core generates Earth's magnetic field, a protective bubble that shields all life from cosmic radiation. Scientists determine these temperatures indirectly, through seismic waves and laboratory experiments that mimic extreme conditions. What's most humbling is that we walk daily above an inferno comparable to a star, separated by only a thin rocky crust. Our world balances between cosmic cold above and stellar heat below, life flourishing in the narrow gradient between these extremes. Make watches from the solar system's edge, a world named for the creator deity of Rapa Nui. This dwarf planet, discovered in 2005, orbits in the Kuiper Belt beyond Neptune, taking 305 Earth years to complete one journey around the Sun. In 2016, astronomers discovered its only known moon, a tiny dark companion unofficially nicknamed MK2. Make's surface appears reddish from methane ice that absorbs certain wavelengths of sunlight. No spacecraft has ever visited this distant world. All we know comes from telescopic observations across vast distances. In the darkness where sunlight dims to twilight, Make continues its patient circuit, a reminder of how many worlds remain beyond our reach, known only by the faintest glimmers of reflected light. Solar prominences reach from the Sun like incandescent bridges to nowhere. These vast glowing arcs of plasma can extend hundreds of thousands of kilometers, a distance that could encompass more than 10 Earths. Held aloft by magnetic fields that loop from the Sun's surface, these structures sometimes remain stable for weeks before collapsing back into the stellar surface or erupting into space. Astronomers study them through specialized telescopes that filter the Sun's blinding light. Some prominences dance and change over just a few minutes. Others hold their shape with eerie stillness. Their fiery beauty belies their destructive potential. If directed toward Earth, they can trigger geomagnetic storms. In their delicate, suspended arch, we witness the Sun's magnetic breath, held for a moment before release. Mars wears white caps that wax and wane with the seasons. Its polar regions host ice caps composed of both water ice and frozen carbon dioxide, dry ice that sublimates directly from solid to gas when warmed by summer sunlight. This seasonal breathing expands the caps in winter and shrinks them in summer, changing the planet's appearance as viewed through telescopes. The process transfers significant amounts of the thin Martian atmosphere from pole to pole throughout the year. Beneath the seasonal layer of carbon dioxide lies a permanent cap of water ice, a potential resource for future exploration. Like a planet caught between two states of being, Mars reveals its transitional nature through these rhythmic changes, neither fully alive with Earth's dynamism nor completely static like Mercury's unchanging face. Between here and elsewhere stretches a boundary visible only to scientific instruments. The heliopause marks where our Sun's influence yields to interstellar space, where the solar wind's outward pressure balances perfectly against the pressure of the galactic medium. Voyager 1 crossed this threshold in 2012, becoming humanity's first interstellar messenger. At this frontier, approximately 123 astronomical units from the Sun, the magnetic field changes direction and cosmic rays from distant stars suddenly increase. No human eye could discern this crossing. The sky remains black, the sun just another bright star. Yet in this invisible transition lies the true edge of our solar neighborhood. Not a wall, but a gentle fading, where what belongs to us becomes what belongs to the galaxy. Callisto bears the marks of eons written in craters. Jupiter's second largest moon wears the most heavily cratered surface in our solar system, a face unchanged for 4 billion years. Unlike its sibling moons that have erased their impact scars through geological activity, Callisto preserves every collision in a frozen record. Lacking internal heat for volcanism or plate tectonics, its ancient surface has remained essentially unchanged since formation. Scientists value this pristine history, a window into the early solar system when impacts were much more frequent. The largest structure, Valhalla Basin, features concentric rings spanning 3,800 kilometers. In Callisto's quiet preservation of time, we find a museum of cosmic memory where nothing is forgotten and change comes only from above. Every August, Earth drifts through cosmic debris, creating a celestial light show. The Perseid meteor shower occurs when our planet passes through the trail of dust and small particles left behind by Comet Swift-Tuttle in its 133-year orbit around the Sun. As these tiny fragments, most no larger than grains of sand, enter our atmosphere at 59 kilometers per second, they burn up from friction, creating streaks of light across the night sky. Ancient cultures saw these regular visitors as tears of gods or souls of the departed. The Perseids have been observed for over 2,000 years, mentioned in Chinese records dating to 36 CE. In this annual encounter between Earth and comet remnants, we witness a brief, beautiful intersection of cosmic paths that were set in motion long before humanity existed. At Saturn's North Pole spins a perfect hexagon, defying our expectations of nature's patterns. This six-sided jet stream encircles a massive hurricane, each of its straight sides approximately 30,800 kilometers long, longer than Earth's diameter. Discovered by the Voyager missions and later studied in detail by Cassini, this geometric formation has persisted for decades, possibly centuries. Wind speeds reach 320 kilometers per hour along this hexagonal boundary. No other planet shows such a distinctly geometric feature, and scientists still debate the fluid dynamics that create and maintain these straight edges. Perhaps most striking is the sheer scale of this pattern, a near-perfect shape that emerged spontaneously from chaos. In Saturn's hexagon, mathematics and nature become one, revealing order where we expect only turbulence. Our entire solar system is adrift in the galaxy, completing one vast orbit every 225 to 250 million years. This cosmic year carries us around the Milky Way's center at approximately 828,000 kilometers per hour. A journey so immense that the last time we occupied our current galactic position, dinosaurs had not yet evolved on Earth. As we travel, the Sun oscillates up and down through the galactic plane like a horse on a carousel. Our spiral arm itself rotates more slowly than we orbit within it, meaning we gradually pass through different galactic environments. The solar system has completed only about 20 such orbits since its formation. In our perception of cosmic stability lies an illusion. We are travelers on an unimaginably grand migration through the galaxy. Uranus whispers to space through a tilted magnetic voice. Unlike Earth, where the magnetic field roughly aligns with the rotation axis, Uranus's magnetic field is tilted 59 degrees from its spin axis and offset from the planet's center. This bizarre configuration, discovered by Voyager 2 in 1986, creates a magnetic field that tumbles asymmetrically as the planet rotates. Scientists believe this strange alignment may result from the planet's interior structure, or from the same ancient impact that knocked Uranus onto its side. The field itself is stronger than Earth's, but weaker than Jupiter's or Saturn's. In this lopsided magnetic presence, we glimpse another of Uranus's many peculiarities, a planet that seems to break every rule of how worlds should behave. Haumea spins itself into an egg-like shape at the edge of our perception. This distant dwarf planet in the Kuiper Belt rotates completely in just 4 hours, so rapidly that its own mass is distorted by centrifugal force. Rather than the expected sphere, Haumea stretches into an elongated ellipsoid, roughly twice as long as it is wide. Discovered in 2004, it orbits the Sun once every 285 years and possesses 2 small moons and a pale ring. Its rapid rotation likely resulted from an ancient collision that also created a family of smaller objects sharing similar orbits. Despite being composed largely of ice, Haumea's surface appears surprisingly bright, a crystal world spinning through darkness. In its peculiar form, we find evidence that even at the solar system's edges, violent events reshape worlds into unexpected configurations. Venus hides beneath a veil of perfect poison. Its clouds consist primarily of sulfuric acid droplets, suspended in a carbon dioxide atmosphere, creating the most reflective surface of any planet, the bright evening or morning star visible from Earth. These yellowish clouds completely obscure the surface, circling the planet every 4 Earth days with winds reaching 360 kilometers per hour. The Soviet Venera landers that penetrated this caustic barrier in the 1970s and 80s survived only briefly in the hostile environment below. Perhaps most striking is how this deadly atmosphere creates the most beautiful planet when viewed from space, a perfect pearl against the black. In Venus's deceptive splendor lies a reminder that beauty sometimes conceals the most inhospitable realities. Asteroid Bennu drifts through space, carrying the chemical signature of our solar system's birth. With a diameter of approximately 500 meters, about the height of the Empire State Building, this carbon-rich space rock has become one of our most studied celestial neighbors. NASA's OSIRIS-REx mission not only mapped its surface, but collected samples from this ancient body in 2020, returning them to Earth in 2023. Bennu's surface is surprisingly dynamic, with particles occasionally ejecting from it for reasons still not fully understood. Its orbit brings it uncomfortably close to Earth every 6 years, with a small probability of impact in the late 22nd century. In this unremarkable-looking rubble pile orbits a messenger from the dawn of our planetary system, a dark archive of cosmic history. Our moon performs a patient waltz of departure. Each year, Earth's lone satellite slips approximately 3.8 centimeters farther from us, about the same rate at which your fingernails grow. This gradual retreat has been precisely measured since the Apollo missions placed reflectors on the lunar surface, allowing scientists to bounce lasers off the moon and time their return. The separation occurs because Earth's rotation transfers energy to the Moon through tidal forces. In the distant past, the Moon appeared much larger in our skies. In the far future, it will seem noticeably smaller. Total solar eclipses, where the Moon perfectly covers the Sun's disk, will eventually become impossible. Like all cosmic relationships, ours with the Moon exists in slow transition, neither permanent nor fleeting, but gracefully evolving across deep time. The solar system's age lies written in stone, not on planets, but within meteorites. Through radiometric dating of isotopes in these space travelers, scientists have determined our cosmic neighborhood formed approximately 4,568 billion years ago. The most ancient meteorites contain calcium-aluminum-rich inclusions that solidified first as the protoplanetary nebula cooled. These primordial timepieces use the predictable decay of radioactive elements as cosmic clocks. Each meteorite that falls to Earth brings an untouched sample of that distant time, preserving material unchanged since the solar system's first moments. The precision of this dating, accurate to within a few million years despite measuring billions, represents one of science's most remarkable achievements. In these ordinary-looking rocks lies the calendar of creation, marked in atoms rather than days. Triton circles Neptune with quiet rebellion. This frozen moon, nearly the size of our own, travels backward compared to most moons, orbiting in a retrograde direction that defies the prevailing pattern. This unusual motion suggests Triton didn't form alongside Neptune, but was captured from the Kuiper Belt, perhaps once a dwarf planet similar to Pluto. Voyager 2's 1989 flyby revealed a surface of frozen nitrogen marked with strange cantaloupe terrain, and active nitrogen geysers erupting from the southern polar cap. Tidal forces from Neptune heat Triton's interior, making it one of the few geologically active moons in the outer solar system. In its backward journey, Triton spins a story of cosmic capture and adaptation, a world finding new purpose in an adopted orbit. At the Sun's core, matter transforms into pure energy. Every second, our star converts 600 million tons of hydrogen into helium through nuclear fusion, releasing the light that sustains all life on Earth. This process occurs under crushing pressure and temperatures of 15 million degrees Celsius. The energy created takes between 10,000 and 170,000 years to reach the Sun's surface, slowly working its way through the dense interior. Only then does it escape as light, reaching Earth in just over 8 minutes. Despite this enormous rate of consumption, the Sun has sufficient hydrogen to continue shining for another 5 billion years. In each photon warming, your skin lies energy born in an ancient atomic transformation, a touch connecting you directly to the star's beating heart. Mars measures its days in a rhythm strikingly similar to our own. A Martian day, called a sol, lasts 24 hours and 37 minutes, just slightly longer than Earth's. This coincidental similarity means that a human on Mars would experience a familiar day-night cycle, with only a gradually shifting time sense. The planet's axial tilt of 25 degrees compared to Earth's 23.5 even creates seasons of comparable length, though much more extreme due to Mars' elliptical orbit. Rovers exploring the Martian surface operate on Mars time, with mission controllers temporarily adjusting their schedules to match. In this cosmic coincidence of timekeeping, Mars offers a strange comfort, a world both alien and familiar, keeping nearly the same hours as we do in its silent desert expanses. Eris waits in darkness, an ice world more massive than Pluto. This dwarf planet, whose discovery helped prompt the reclassification of Pluto, orbits in the scattered disk beyond Neptune, a region where objects have been pushed into more extreme orbits by Neptune's gravity. A full orbit takes Eris 558 Earth years, and its highly tilted path carries it far above and below the main plane of the solar system. Its surface is covered with methane ice that gives it a pale reflection despite its great distance. Eris has one known moon, Dysnomia, named like its parent for figures associated with discord in Greek mythology. In its isolated journey through the outer darkness, Eris represents one of many worlds in a region we've only begun to explore, each a unique chapter in our system's complex story. Saturn's rings contain delicate structure within seeming uniformity. What appears as smooth bands from a distance resolves into thousands of individual ringlets separated by gaps, some as narrow as 10 meters, others spanning thousands of kilometers. The Cassini division, the most prominent gap, extends 4,800 kilometers and was observed by Giovanni Cassini in 1675 with a primitive telescope. These spaces result from gravitational resonances with Saturn's moons, which shepherd ring particles and create orbital harmonies. The rings themselves are remarkably thin, just 10 meters in most places, despite spanning 280,000 kilometers from edge to edge. If scaled to the thickness of a sheet of paper, they would cover a football field. In this ethereal architecture of ice and dust, mathematics manifests as visible beauty. The center of our solar system isn't precisely the sun's center. The barycenter, the common center of mass, around which all objects orbit, lies sometimes within the sun, but often outside it, depending on the positions of the planets, especially massive Jupiter. This gravitational focal point constantly shifts as the planets move in their orbits, causing the Sun itself to wobble slightly. Astronomers hunting distant exoplanets use this same wobble effect in other stars to detect unseen worlds. Every 1186 years, Jupiter returns to the same position, creating a regular pattern in this solar dance. Nothing truly orbits anything else. Rather, all bodies orbit their common center of mass in a complex gravitational choreography. In this subtle shifting of the system's heart, we see gravity's democratic nature. Even the smallest body exerts its influence. Europa hides an ocean beneath its fractured ice, a sea containing more water than all Earth's oceans combined. This moon of Jupiter presents a surface crisscrossed with cracks, where the ice shell, estimated to be 15 to 25 kilometers thick, has repeatedly broken and refrozen. The liquid water beneath remains unfrozen due to tidal heating. Jupiter's enormous gravity flexes Europa's core as it orbits, generating internal warmth. The Hubble Space Telescope has observed occasional water plumes erupting through cracks, reaching 200 kilometers above the surface. Scientists consider Europa one of the most promising places to find extraterrestrial life in our solar system. In this hidden realm, sealed beneath ice and bathed in radiation, life might find its own path, perhaps gathering around deep hydrothermal vents as it once did on primordial Earth. The Carrington event reminds us of the Sun's explosive potential. In 1859, astronomer Richard Carrington observed an intense solar flare, followed 17 hours later by a geomagnetic storm that created auroras visible even at tropical latitudes. Telegraph systems sparked and operated without power. Operators received electric shocks. This remains the most powerful solar storm in recorded history, releasing energy equivalent to 10 billion 1-megaton nuclear bombs. Modern estimates suggest a similar event today would cause trillions in damage to our technological infrastructure and potentially leave parts of the world without power for months. Solar observatories now monitor our star continuously for similar eruptions, providing warning of incoming storms. In our dependence on electronics lies a vulnerability to the star that sustains us. Its occasional temper capable of temporarily returning our civilization to a pre-electrical age. Mercury follows an eccentric path unlike any other planet. Its highly elliptical orbit brings it as close as 46 million kilometers to the Sun at perihelion and as far as 70 million kilometers at aphelion, a distance variation of over 50%. This creates dramatic changes in apparent solar size when viewed from Mercury's surface. At its closest approach, the Sun would appear 3 times larger than it does from Earth. This orbital eccentricity puzzled classical astronomers and was fully explained only by Einstein's general relativity, which accounted for small discrepancies in Mercury's orbital precession that Newtonian physics couldn't explain. In the subtle wobble of Mercury's orbit, Einstein found crucial evidence for his revolutionary theory of curved spacetime. Through its peculiar journey, the smallest planet helped reveal the deepest nature of space itself. Our solar system hosts a vast family of moons, over 200 natural satellites, orbiting planets and dwarf planets. These worlds range from tiny captured asteroids just kilometers across to planet-sized satellites like Ganymede and Titan. Each moon tells its own story. Some formed alongside their parent planets, others were captured, and still others resulted from massive collisions. Most follow prograde orbits in their planet's equatorial plane, but dozens orbit backward or at steep angles. The outer planets hold the majority, with at least 95 moons orbiting Jupiter and 146 circling Saturn as of 2025. Many remain unnamed or bear only provisional designations. In this diverse collection of secondary worlds, we find as much variety and complexity as in the planets themselves, each a unique chapter in the system's evolution. Uranus breathes air unlike any we could inhale. Its atmosphere consists primarily of hydrogen and helium, similar to Jupiter and Saturn, but contains a higher percentage of methane, about 2.3%. This methane absorbs red light and reflects blue and green wavelengths, giving Uranus its distinctive cyan color. Deeper within lie layers of water, ammonia, and methane ices surrounding a small rocky core. Unlike the visually dynamic Jupiter and Saturn, Uranus presents few visible features in its atmosphere, appearing as a nearly featureless blue-green sphere. The Voyager 2 flyby in 1986 revealed only about 10 cloud features in the entire visible hemisphere. In Uranus's quiet monochromatic face, we find a world that keeps its complexity hidden, its storms and structures concealed beneath the serene upper atmosphere that meets our gaze. The asteroid belt, despite its vastness, contains surprisingly little matter. The combined mass of every asteroid between Mars and Jupiter amounts to just 4% of our Moon's mass, less than would form a single small terrestrial planet. This cosmic rubble field consists of millions of objects, from microscopic dust to Ceres, at 940 kilometers diameter, yet spread over such an enormous volume that the average distance between significant asteroids exceeds 20 million kilometers. A spacecraft passing through would likely never see a single asteroid without deliberately aiming for one. Jupiter's gravity prevented this material from accumulating into a planet during the solar system's formation, instead keeping it perpetually fragmented. In this sparse collection of primordial leftovers, we find not a barrier but a preserved fossil of our system's earliest days. Venus wears a face of fire beneath its cloudy veil, Its surface features more than 1/600 major volcanoes and countless smaller ones, though whether any remain active is unknown. Vast volcanic plains cover 80% of the planet, with highland regions rising above them like continents on an ocean of solidified lava. The Magellan spacecraft mapped these features using radar to penetrate the thick atmosphere, revealing a landscape shaped almost entirely by volcanism. Unlike Earth, with its dynamic plate tectonics, Venus may experience periodic global resurfacing events where the entire crust melts and reforms. The most recent such catastrophe may have occurred 300–600 million years ago. In Venus's frozen fire, we glimpse a possible alternative path for Earth, a reminder that similar beginnings can lead to vastly different planetary fates. Between too hot and too cold stretches a ribbon of cosmic possibility. The habitable zone, the region around a star where liquid water can exist on a planet's surface, extends in our system from approximately 0.95 to 1.37 astronomical units from the Sun. Earth orbits comfortably within this Goldilocks zone, while Venus falls just inside the inner edge and Mars just beyond the outer boundary. The precise boundaries shift over time as the Sun slowly brightens. This concept guides astronomers in their search for potentially habitable exoplanets around other stars, where different stellar temperatures create habitable zones at different distances. Within this narrow band of orbital real estate lies the greatest likelihood for finding worlds with surface conditions similar to Earth. In this slender arc of possibility, we find ourselves perfectly positioned, neither too close nor too far from our star's warming light. Titan drifts through Saturn's orbit, wrapped in Earth-like air without Earth-like composition. This moon's thick atmosphere consists primarily of nitrogen, just like our own, but contains methane rather than oxygen as its secondary component. Titan is the only moon with a substantial atmosphere, so dense that its surface pressure exceeds Earth's by 50%. This atmospheric blanket creates familiar weather patterns with methane clouds, rain and rivers carving channels into a surface of water ice as hard as rock in Titan's minus 179 degrees Celsius environment. The Huygens probe, which landed on Titan in 2005, revealed an orange-hued world where complex organic chemistry occurs continuously in the atmosphere. In Titan's strange familiarity, we find a laboratory for understanding early Earth, perhaps resembling our world before oxygen transformed it billions of years ago. Voyager 1 carries humanity's greeting card to the stars. This spacecraft, launched in 1977, has traveled over 23 billion kilometers, farther than any other human-made object. It crossed the heliopause in 2012, entering true interstellar space, yet continues to transmit data back to Earth with a signal so faint it registers at just 1/billionth of a watt when received. Traveling at 17 kilometers per second, Voyager 1 will pass within 1.6 light-years of the star AC+ 793A8 in the constellation Camelopardalis, but not for another 40,000 years. Alt-Ehrich carries a golden record containing sounds and images selected to portray Earth's diversity of life and culture. In this tiny messenger's eternal journey lies our first tentative reach beyond our solar cradle, a technological whisper that will outlast our civilization and possibly our species. Jupiter's depths hide a state of matter found nowhere on Earth. As atmospheric pressure increases with depth, hydrogen gas gradually compresses into an exotic liquid metal capable of conducting electricity like copper wire. This metallic hydrogen layer, beginning approximately 20,000 kilometers below the cloud tops, generates the planet's enormous magnetic field as it flows around the central core. The transition occurs at pressures exceeding 2 million times Earth's atmospheric pressure, conditions scientists can only briefly replicate in specialized laboratory experiments. No spacecraft could survive these crushing depths to directly observe this strange state of matter. In Jupiter's hidden heart lies a reminder that familiar elements behave in unfamiliar ways under extreme conditions. The periodic table's simplest atom transformed into something altogether alien by the sheer weight of a world pressing down upon it. Pluto traces a path through the cosmos that speaks of patience and persistence. Its highly elliptical orbit carries this distant world 248 Earth years to complete one journey around our Sun, moving from as close as 30 astronomical units to as far as 49. As you sleep tonight, Pluto continues this ancient rhythm, traversing the darkness with unhurried grace. When it was last in its current position, the American Revolution had just begun. When it returns, generations yet unborn will look up at the same stars we see. There's comfort in knowing that some journeys unfold too slowly for a single human life to witness, yet continue regardless. A reminder that we are part of something far greater than our brief moment in time. The light within you travels with impossible subtlety. Solar neutrinos, born in nuclear fusion at the Sun's core, pass through Earth as if it were hardly there. Trillions flow through your body every second, through bone and blood and brain. Yet you never feel their gentle touch. These ghost-like particles rarely interact with matter, making them nearly impossible to detect despite their abundance. Scientists have built vast underground pools filled with purified water to catch just a handful. They are messengers from our star's heart, carrying information from places we could never visit. When you feel sunlight on your skin, remember that something more profound has already passed through you, connecting your being directly to the nuclear furnace that gives us life. Mars cradles a canyon that would span the continental United States. Valles Marineris stretches 4,000 kilometers long and plunges 7 kilometers deep, a wound in the red planet's crust that dwarfs our Grand Canyon. If placed on Earth, it would reach from Los Angeles to New York, revealing depths no human eye has directly witnessed. This vast chasm likely formed as Mars' crust stretched and fractured, then expanded through erosion and landslides over billions of years. When you feel small beneath your own night sky, remember that we live in a solar system of magnificent scale, where even our most impressive landscapes find humbling counterparts. Our sense of wonder grows not from conquering such vastness, but from allowing ourselves to be beautifully diminished by it. The story of our origins falls gently to Earth every day. Meteorites, ancient messengers from the solar system's birth, continue to land on our planet, carrying evidence of how we began 4.6 billion years ago. Some contain amino acids, the building blocks of life. Others preserve pristine material unchanged since the solar nebula first condensed. When you hold a meteorite, you touch something older than Earth itself, a fragment that witnessed the beginning. Each night as you rest, tiny cosmic dust particles settle through our atmosphere, a constant gentle rain of stardust covering our world. We build our homes and lives on a foundation of cosmic gifts, each of us walking atop the accumulated history of our solar neighborhood. connected by touch to the very stuff that made us possible. Neptune wears the color of peaceful meditation. Its striking blue hue comes from methane in its atmosphere, absorbing the red wavelengths of sunlight, reflecting back only the blues that reach our eyes. This distant world, named for the Roman god of the sea, truly embodies its oceanic namesake in appearance. Though we've only visited it once, when Voyager 2 flew past in 1989, its serene blue presence continues to captivate our imagination. When you seek calm in moments of stress, picture Neptune's steady azure glow at the edge of our planetary family, maintaining its quiet beauty despite violent storms beneath its surface. Some worlds remind us that even in turbulence, we can present a peaceful face to the universe, reflecting back the most tranquil parts of ourselves. Deep in the asteroid belt floats a treasure beyond measure. Asteroid Psyche, about 226 kilometers across, appears composed largely of metallic iron and nickel, similar to Earth's core but exposed to space. If brought to our world, its metals would exceed the value of our entire global economy. NASA's spacecraft journey to this metallic world will teach us about the hidden hearts of planets, including our own. Yet Psyche's true value isn't monetary, but in what it reveals about our formation. As you drift towards sleep, imagine this island of metal orbiting silently in the darkness, a remnant perhaps of a shattered ancient protoplanet. We find pieces of ourselves scattered throughout our cosmic neighborhood, each one offering another page in the story of how we came to be. Earth's protective shield has a curious habit of reinventing itself. Our planet's magnetic field, which shields us from harmful solar radiation, reverses its polarity approximately every 450,000 years on average. North becomes south, south becomes north, in a slow dance of electromagnetic forces generated by Earth's liquid outer core. We live in an overdue period, as the last full reversal occurred 780,000 years ago. During transitions, the field weakens before re-establishing in the opposite direction. You've only known one configuration of this invisible protector in your lifetime, but Earth has known many. There's wonder in realizing we exist within planetary rhythms, too slow for human experience, yet vital to our survival. Cosmic breaths drawn over spans that make civilizations seem like moments. Iapetus teaches us that beauty often lies in contrast. This moon of Saturn wears two distinctly different faces, one hemisphere dark as charcoal, the other bright as snow. This two-tone coloration puzzled astronomers since its discovery by Cassini in 1671. We now understand that dark dust from another of Saturn's moons, Phoebe, spirals inward and collects on Iapetus's leading hemisphere as it orbits. The temperature difference between dark and light regions creates a feedback loop that enhances the contrast. In your own life, you may find that apparent opposites create the most compelling wholes. Like this distant moon, we contain multitudes, light and shadow, joy and sorrow, not in conflict, but in completion. Our contradictions don't diminish us, they make us whole. Our solar system tells a story of beautiful diversity within unity. Its planets divide naturally into two families: the rocky terrestrial worlds of the inner system and the massive gas giants beyond. Mercury, Venus, Earth and Mars formed where temperatures were high enough for only rock and metal to condense. Jupiter, Saturn, Uranus and Neptune coalesced where water, ammonia and methane could freeze into ices. Yet all 8 worlds emerge from the same swirling nebula, children of the same cosmic parent. As you rest tonight, remember that differences in nature often reflect not separate origins, but adaptive responses to varying environments. We too are one family on our shared Earth. Our differences the beautiful result of adaptation to diverse conditions across our planetary home. 4 worlds witnessed the dawn of modern astronomy through human eyes. Jupiter's largest moons, Io, Europa, Ganymede, and Callisto, were first glimpsed by Galileo in 1610, earning them the name Galilean satellites. When he turned his primitive telescope skyward and saw these points of light orbiting another world, our understanding of the cosmos forever changed. Each night, these same moons continue their dance around Jupiter, visible even through modest binoculars. What Galileo observed with wonder, you can see with your own eyes tonight. There's profound connection in knowing that across 4 centuries of human progress and change, these distant worlds remain constant companions in our night sky. A shared experience linking you directly to those who looked up in ages past. At the farthest edge of our vision waits a world of extreme patience. The dwarf planet Sedna travels one of the most distant and elongated orbits known, requiring 11,400 years to circle the Sun once. Its reddish surface reflects little light as it journeys from 76 to 937 astronomical units away, distances almost beyond comprehension. When Sedna last approached its closest point to the Sun, humans were just beginning to develop agriculture. When it returns, what will Earth's inhabitants be like? As you close your eyes tonight, Sedna continues its lonely voyage through the outer darkness, a tiny ember at the edge of our solar family. In its extreme orbit, we find perspective on our brief lives, a reminder that the universe operates on timescales that make our urgent concerns seem wonderfully small. Venus turns with such deliberate slowness that it challenges our sense of time. A single day on this cloud-wrapped world lasts longer than its entire year. 243 Earth days to rotate once on its axis, while taking only 225 days to orbit the Sun. If you lived on Venus, you would see the sun rise in the west, crawl slowly across the sky, and set in the east over a period of 118 Earth days. This cosmic patience reminds us that time is relative to perspective. In your busy life, there is value in occasionally embracing Venus-like slowness, allowing yourself to move at a pace that might seem strange to others, but feels right to you. Not all rhythms need to match. The solar system itself celebrates different tempos, each perfect for its own world. Between Mars and Jupiter lies a band of possibilities that never quite became whole. The asteroid belt represents material that Jupiter's massive gravity prevented from forming into a planet. Millions of rocky fragments orbit here, from dust particles to Ceres at 940 kilometers across. Their combined mass equals just 4% of our moon, remnants of what might have been. Yet, in this cosmic interruption, life on Earth found opportunity. Many meteorites that have shaped Earth's development came from this region. The belt's existence helped shield our inner solar system from some impacts, creating conditions for life to flourish here. What appears as cosmic failure from one perspective becomes blessing from another, a pattern you might recognize in your own life's unexpected turns. Uranus and Neptune embodied the beautiful blending of categories. Known as ice giants, these distant worlds exist between definitions, not quite gas giants like Jupiter and Saturn, yet far larger than rocky worlds like Earth. Their blue-green hues come from atmospheres rich in frozen water, methane, and ammonia surrounding small rocky cores. Though similar in size and composition, each developed its own character. Neptune with fierce storms and strong winds, Uranus tipped on its side in perpetual season. As you drift toward sleep, consider how you too may resist simple categorization. The most interesting things often exist in the spaces between defined boundaries. Like these twin worlds at our system's edge, your complexity is not a flaw but a feature, worthy of exploration and understanding. The solar wind carries our star's influence with diminishing whispers. This stream of charged particles flows outward in all directions, but its pressure decreases with the square of the distance from the Sun, becoming 4 times weaker when twice as far away. By the time it reaches Earth, this silent breath is gentle enough that our magnetic field can shield us, yet strong enough to shape our planet's magnetosphere into a teardrop extending millions of kilometers behind us. When auroras dance in polar skies, you're witnessing our atmosphere responding to this solar touch. The universe speaks to us in forces that diminish but never disappear completely. Just as the influence of those you love remains even at great distances, the Sun's presence extends far beyond its visible light. 2 tiny moons keep silent watch over the red planet. Mars's satellites Phobos and Deimos, named for the Greek gods of fear and terror, were discovered in 1877 by American astronomer Asaph Hall after nearly giving up his search. These irregular bodies, just 22 and 12 kilometers across, orbit their parent with different destinies. Phobos circles so closely it will eventually spiral inward and break apart, while more distant Deimos may one day escape. The same persistent human curiosity that found these moons continues today as rovers explore the Martian surface. When you face challenges that tempt you to abandon your search, remember Asaph Hall, who nearly quit just days before his discovery. Sometimes the universe reserves its gifts for those willing to look just a little longer. The cosmic dance of our solar system moves with mathematical grace. The total angular momentum, the combined rotational energy of the Sun, planets, and their moons, remains nearly constant since its formation, redistributed but never lost. Remarkably, while the Sun contains 99.8% of the system's mass, Jupiter and Saturn hold most of the angular momentum through their mass, distance, and orbital velocity. This balance reflects the process of our birth from a spinning nebula. As you rest tonight, you participate in this same conservation, your body turning with Earth, orbiting the Sun, spiraling through the galaxy. We sometimes forget that even in stillness, we're in constant, graceful motion. Part of an elegant equation set in motion billions of years ago, each of us a term in its balanced solution. Saturn's rings appear substantial from afar, yet contain surprising delicacy. Despite spanning 280,000 kilometers from edge to edge, these magnificent bands measure just 10 meters thick in most places. If scaled to the thickness of a sheet of paper, they would cover a football field. Billions of ice particles, from microscopic dust to house-sized chunks, orbit in this nearly 2-dimensional plane, reflecting sunlight back to our wondering eyes. The Cassini spacecraft's final dive between the rings and planet revealed them to be 95% empty space. What lessons might we find in something so visually striking yet materially sparse? Perhaps that beauty doesn't require solidity, that spaces between things hold as much importance as the things themselves, and that emptiness itself can become the canvas for cosmic art. The Kuiper Belt holds memories of our earliest days. This ring of icy worlds beyond Neptune contains remnants unchanged since the solar system's formation, 4.6 billion years ago. Primordial material preserved in deep freeze. Here orbit Pluto and its siblings, comets in waiting, and countless unnamed worldlets still bearing the chemical signatures of our system's birth. When comets from this region occasionally visit the inner solar system, they bring ancient material back to our neighborhood. Each night as you sleep, these distant objects continue their slow orbits in perpetual twilight, where the sun appears as just the brightest star. There's comfort in knowing that while our lives constantly change, parts of our cosmic neighborhood remain as they were at the beginning. Quiet libraries preserving the earliest chapters of our shared story. Jupiter stands as our planetary system's ancient protector. Its enormous gravitational influence has shielded the inner solar system from countless potential asteroid and comet impacts throughout our history. Like a cosmic goalie, it deflects or captures many objects that might otherwise threaten Earth. The Shoemaker-Levy 9 comet impact in 1994 demonstrated this protective role as Jupiter absorbed fragments that could have caused mass extinction had they struck our world. Without this guardian's presence, life on Earth might never have evolved stable ecosystems or complex forms. As you rest peacefully tonight, Jupiter continues its silent vigil, its storms and swirling clouds concealing a role far more significant than mere beauty. In its massive presence, we find an unexpected partner in our evolutionary journey, a distant shield that helped make our story possible. Our solar system moves with rare cosmic harmony. All 8 planets orbit the Sun in the same direction, called prograde motion, following the rotation of the original nebula from which they formed. Only Venus breaks this pattern in its rotation, turning backwards on its axis in a rebellious spin. This shared directional flow reflects our common origin from a single collapsing cloud of gas and dust. The mathematical beauty of these aligned orbits, nearly circular and nearly within the same plane, speaks to the ordered emergence of our planetary home. When life feels chaotic, remember that you exist within a system of profound underlying order, your feet planted on a world that follows cosmic patterns established billions of years ago, your eyes gazing outward from a platform of remarkable stability. Neptune came to us first through mathematics, then through sight. This distant blue world became the first planet discovered through theoretical prediction rather than direct observation. In 1846, astronomers noticed Uranus wasn't following its expected orbit and calculated that an unknown planet's gravity must be the cause. When telescopes pointed to the mathematically predicted location, Neptune was there, waiting to be found. This triumph of human reason revealed how deeply we can understand reality through numbers and equations. The universe follows patterns we can learn to read, sometimes finding what exists before we see it. As your mind drifts toward dreams, consider how the unseen often shapes the scene, how invisible forces guide visible objects, and how mathematics itself becomes a kind of cosmic vision that extends beyond our eyes. Ceres whispers secrets of water where we least expected it. This dwarf planet, nestled in the asteroid belt, surprised astronomers when the Dawn spacecraft detected water vapor plumes erupting from its surface. Beneath its dusty exterior lies evidence of a subsurface ocean that once flowed and may still exist in pockets. In a region once thought to be dry and dead, we found signs of the very molecule that makes life on Earth possible. The universe has a way of challenging our assumptions, hiding potential in places we overlooked. As you rest tonight, consider what possibilities might exist in the overlooked corners of your own life. Like Ceres hiding water in the seemingly barren asteroid belt, your challenges may contain unexpected resources, waiting just beneath the surface of awareness. Earth's air tells the story of life's profound influence. Our atmosphere has transformed dramatically over billions of years, with oxygen levels rising significantly only after photosynthetic organisms appeared. What you breathe tonight, this invisible mixture that keeps you alive, was largely created by countless generations of plants and microbes. Every molecule entering your lungs connects you to this planetary history and to all other breathing beings. The oxygen sustaining you was likely released by plants within the past few thousand years, making each breath remarkably fresh on geological timescales. Our planet breathes with you, its composition forever altered by life itself. In this circular relationship, life created the conditions for more life, a beautiful cooperation spanning billions of years that continues with each rise and fall of your chest. The asteroid belt contains families that travel together through time. Numerous groups of asteroids share similar orbital characteristics, compositions, and origins. Fragments from ancient collisions that scattered related pieces across similar paths. Astronomers identify these families through mathematical clustering analysis, revealing their common heritage despite their separation. The Vesta family, for example, consists of pieces ejected when a massive impact created a crater on asteroid Vesta billions of years ago. These cosmic relatives continue their journey around the Sun, carrying shared memories of their violent birth. In your own life, connections may persist despite physical distance. Like asteroid families, we carry the signatures of shared experiences with us as we move through our individual orbits, invisibly connected by our common origins and interactions. Beneath Enceladus's icy shell flows an unexpected ocean of possibility. This small moon of Saturn, just 500 kilometers across, contains a global subsurface ocean kept liquid by tidal heating, Saturn's gravity flexing its core as it orbits. Through cracks near its south pole, plumes of water vapor erupt into space, carrying salt and organic compounds. These ingredients, essential for life as we know it, exist in the darkness beneath the ice. The Cassini spacecraft flew through these plumes, tasting their composition directly. When life seems impossibly fragile on our warm, hospitable Earth, remember that even in the cold darkness of Saturn's orbit, the potential for life's chemistry persists. Our understanding of where life might emerge grows with each discovery, expanding the boundaries of hope beyond our once limited imagination. Our solar system has witnessed over a third of cosmic time. At 4.6 billion years old, our planetary home has existed for more than 1/3 of the universe's total age of 13.8 billion years. Stars lived and died before our Sun formed, creating the heavier elements that make up our world and bodies. We are not latecomers to cosmic history, but have been present for a significant portion of universal time. As you close your eyes tonight, you rest within a mature planetary system that has experienced most of what the universe has to offer. There's comfort in this continuity, in knowing that while human history spans just a moment, the matter composing you has been part of this grand story for billions of years, not just witnessing cosmic history, but embodying it. Mars leans into its seasons with a familiar tilt. Its axial inclination of 25 degrees, remarkably close to Earth's 23.5 degrees, creates seasonal patterns similar to our own, though each Martian season lasts nearly twice as long due to its longer year. When it's summer in Mars's northern hemisphere, the North Pole tilts toward the Sun just as Earth's does during our summer. This cosmic coincidence means that if we ever stand on Martian soil, the rhythm of the seasons would feel strangely familiar, even as the temperature and light differ dramatically from Earth. As seasons change where you are, remember that this same dance of axial tilt and orbital position shapes life across our solar system, binding distant worlds through shared physical principles, creating a subtle harmony that transcends distance. Our solar system's outer worlds all wear rings of ice and dust, while Saturn's magnificent bands first captured human imagination. Uranus, Neptune, and Jupiter also possess ring systems, each with its own character. Uranus's narrow rings appear dark and may contain larger particles. Neptune's incomplete arcs suggest recent formation. Jupiter's faint rings consist of dust ejected from its inner moons. These outer planet rings reflect a common process: small moons shedding material or being disrupted by gravitational forces. What once seemed Saturn's unique feature reveals itself as a family trait of giant planets. As you drift towards sleep, consider how exploring our cosmic neighborhood continually reveals patterns, the universe expressing similar themes across different worlds, reminding us that even in apparent uniqueness, we often find deeper connections. Ganymede carries its own magnetic heart within Jupiter's embrace. This moon, the largest in our solar system, generates an internal magnetic field. The only moon known to possess this planetary feature, deep beneath its icy surface, a molten iron core creates this magnetic bubble within the much larger field of Jupiter itself. The Galileo spacecraft detected this field in 1996, revealing Ganymede's unexpected complexity. Like a child developing its own identity while still under a parent's influence, this distant moon maintains its unique electromagnetic signature while orbiting within Jupiter's powerful field. As you rest tonight, remember that developing your inner inner strength doesn't require separation from larger forces around you. Like Ganymede, your uniqueness can exist harmoniously within the broader fields that surround and support you. As our journey through the solar system begins to slow, the planets and moons seem to dim their light, as if they too are preparing for rest. We've wandered from the metallic heart of asteroid Psyche to the icy plumes of Enceladus, from Jupiter's protective gravitational embrace to Neptune's mathematically predicted discovery. We've explored ancient Kuiper Belt remnants and watched Saturn's impossibly thin rings turning silently in the darkness. Remember that you are part of this cosmic story. The same elements that form distant planets flow through your veins. Earth's magnetic field that reverses every 450,000 years protects you as you sleep. Your home planet spins within this delicate balance of gravity and motion, a perfect cradle for dreams in the vastness of space. As you drift towards sleep, know that Mars continues its slow rotation, Venus its longer than a year day, and Pluto its 248-year journey around our Sun. The solar system will keep its ancient rhythms while you rest, the planets turning like soft thoughts in the night. If you're still awake, there's another journey waiting for you in our next episode. But for now, may your dreams be as peaceful as the distant moons and as deep as the cosmos itself. Good night.